Hey guys, and welcome to the school station. In today's video, I'm going to be talking about recurring decimals. This is from the Edexcel GCSE Maths 9 to 1 paper from the unit number. In today's video, I'm going to be talking about recurring and terminating decimals. So in this video, I'll be talking about the difference between terminating and recurring decimals and how to actually solve questions involving these type of decimals. So let's just get right into the video. So first of all, we actually have to know what is a terminating decimal and what is a recurring decimal. These definitions are really helpful to memorize, so you can go on and pause this video and read them through and try to memorize them. A terminating decimal is when if the prime factor decomposition of the denominator is a power of 2 and 5, then the decimal expansion will be terminating. And recurring decimal is if the prime factor decomposition of the denominator is any number other than the power of 2 and 5, then the decimal expansion will be recurring. So what this simply means is that a terminating decimal, actually if there is the denominator of a particular fraction, if it is in the power of 2 and 5, then it will be a terminating decimal. And for recurring decimals, if there is any fraction that if you see the denominator, they have any other number except the power of 2 and 5. So if they don't fall in the category of powers of 2 and 5, 2 or 5, then you will realize that they're actually not a recurring decimal. So therefore you actually have to, they will be a recurring decimal if they have any number other than the power of 2 or 5. So therefore you basically have to just really think about these definitions while you're going to answer the next few questions. So now over here, I want you guys to pause this video and have a go from looking at the definitions. Which of these are the terminating decimals? We have 6 different fractions over here: 2/3, 3/4, 5/8, 4/9, 5/6, and 3/5. Again, I want you guys to pause this video and have a go on trying to find out which are the terminating decimals without using a calculator. Alright guys, hope you guys have tried. And here is the answer. So, as you guys can see, the answer is 3/4, 5/8, and 3/5. The reason why is because, as I mentioned earlier, terminating decimals we can realize if a fraction is a terminating decimal by looking at the denominator. As you can see in 3/4, we can see the denominator is 4, and we should know that 4 is the power of 2 because 2 squared is 4. Therefore, 3/4 would be a terminating decimal. In the second example, in the second fraction, we can see 5/8. 8 is obviously, again, a power of 2, because 2 to the power of 3 is 8. And then last of all, we have 3/5, and we can see that 5 is obviously a power of 5, so it will be 5 to the power of 1. Therefore, if it is a power of 2 or 5, then it will actually be a terminating decimal. The rest, like 2/3, that 3 is not a power of 2 or 5. We can see that 4/9, if we see 9 is not a power of 2 or 5. And last of all, 5/6, we can see that 6 is not a power of 2 or 5. So therefore, we should realize that these are not going to be terminating decimals. Now we're going to go on to the second question. Over here, we're asked to find which are the recurring decimals. We have 5/12, 7/25, 3/14, 5/16, 5/32, and 5/11. Again, I want you guys to pause this video and have a go on trying to find out which are the recurring decimals out of these. Alright guys, hope you guys have tried out, and here is the answer. We have 5/12, 3/14, and 5/11. So the way I actually solve that is by going through each of the fractions and seeing which are the recurring decimals. For the first one, we checked if 12 from 5/12 is actually a power of 2 or 5. 12 is not a power of 2 or 5 because if we did 2 to the power of something to make 12, it would not be a whole number. So therefore 12 is not a power of 2 or 5. 7/25, we realize that 25 is actually is actually a power of 2 or 5. So therefore, that would have been a terminating decimal, which means that it is not a recurring decimal, because 5 squared is 25, and that would mean that 7 over 25 is a terminating decimal. 3 over 14, if we realize that 14 actually is not a power of 2 or 5, so therefore that will be a recurring decimal. 16 is actually 2 to the power of 4, so this is why this would be a terminating decimal, and this would not be a recurring decimal. 5 over 32, we realize 32 is also a power of 2, and last of all we have 5 over 11. 11 is not a power of 2 or 5, so 5 over 11 is over here. So that's how we spot if they're recurring or terminating decimals. So now that we've clarified how to do terminating recurring decimals, now I actually want to go on to more about recurring decimals and how to actually turn a recurring decimal into a fraction. In this example, we're asked to turn 0.7777 into a fraction. Obviously, this is 0.7 recurring, so therefore we have to turn this into a fraction. I want you guys to pause this video and have a go on trying to find the answer to the solution. If not, you can continue with the video. Alright guys, hope you guys have tried it out, but if not, here is the answer. So first of all, you actually have to just think as 0.7777, which is obviously 0.7 recurring, as x, okay? So what I first of all did was I just wrote x as is equals to 0.7 recurring. After you've written that, you actually have to spot how many numbers after the decimal point are recurring. So over here you can see that this is just 0.7 recurring, and 7 is the only number recurring after the decimal point. So it's one number recurring after the decimal point. Therefore, you just have to realize that, okay, since it is one number that is recurring, you actually just have to write it down. If we actually multiply this by 10, 0.7 is actually going to be 7.7777, and therefore there will be no zeros left. So all we have to do is just multiply x by 10, so it would be 10x is equals to 7.7777. At the same time, if we actually get that x and we put 0.7777, we can actually take away 10x from x to get 9x. So 9x would be 7. So our main aim is to just get a whole number, okay? So that's our main point. We're trying to get a whole number. So if we do 10x is equals to 7.7777 minus x, which is 0.7777, that would be 9x is equals to 7. So after we get this, we just have to use our normal knowledge about equations, which is divide 9 from both sides, and we'll get x is equals to 7 over 9. And that is how you turn 0.7 recurring into a fraction. So the second example over here is turn 0.45454545 into a fraction. I want you guys to pause this video and have a go on trying to solve this. If not, you can continue with the rest of the video. Alright guys, hope you guys have tried out this question, but here is the answer. The answer is 5 over 11. So first of all, as I said, you have to actually recognize that the number that is recurring is 0.45. So 45 is recurring over and over again. So as you can see that there are two numbers recurring this time, not one like last time, it's two numbers that are recurring. 4 is recurring and 5 is recurring, so it's becoming 4, 5, 4, 5, 4, 5, 4, 5. So what we have to do is that since there are two numbers recurring, what we have to do is we have to do 100x, because we just have to add two zeros after the 1 to make it 100x. And if we do 100x, we will basically be multiplying, we would be taking the decimal point and moving it two places to the right. So it would be 45.45454545 and so on. And then we actually have to realize what number, if we do 10x, however, it would actually be 4.545454, and that would basically destroy the pattern that we're leaving over here. So what we're trying to do is we're trying to make all of the numbers cancel out each other like we did on the last example over here. We tried to make 7 cancel each other out, but it was a bit more easier. So in this example, we don't want it to be 5454, because then it would just be a lot of complication. So we're trying to get 44 in one column, 55 in one column. So the way we do it is we actually just leave x into its own form. So x is equals to 0.454545 and so on. 100x minus 1x is 99x, and when we subtract this, we will actually get a whole number, which is 45. Using our basic knowledge of equations, we will divide 99x by 99, so it will be x is equals to 45 over 99, and if we simplify this further, it will become 5 over 11, and you'll realize that this is actually a recurring decimal and we've just turned it into a fraction. So that's basically how you would solve this type of question. You just have to try to get a whole number in the end so that you can put it as a fraction, and you have to try to get the columns so that they basically cancel out each other, so that 4 minus 4 becomes 0, 5 minus 5 becomes 0, 4 minus 4 becomes 0, so everything in this side becomes 0. So I hope you guys have enjoyed this lesson. Just as an overview of what we have learned today, we were actually able to define what a terminating decimal is. We were also able to define what a recurring decimal is. We were able to identify the different types of problems involving terminating and recurring decimals. And last of all, we were also able to turn a recurring decimal into a fraction. I really hope you guys enjoyed this video. Please give this video a thumbs up if this has helped you, and subscribe to the School Station for more free science and maths lessons. Bye guys!